Hi, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today's my topic is exact differential equations and equations made exact by using integrating factors. In previous videos, I solved the exact differential equation related problems, and also if the equation is not exact, how to make it exact by using integrating factor are also discussed in the previous video. Now I am going to see how to use the integrating factor in another model, that is type 2. So here I am going to see the type 2 integrating factor. Suppose if mdx plus ndy is equal to 0 is not an exact equation, and also it is in the form y into f of xy dx plus x into g of xy dy is equal to 0, and also mx minus ny not equal to 0, then the integrating factor of the given equation is 1 by mx minus ny. This is type 2 integrating factor model. In the first model, if the given equation is not exact equation and if it is a homogeneous differential equation with mx plus ny not equal to 0, then we have discussed 1 by mx plus ny is the integrating factor. Integrating factor means if we reach an integrating factor, when you multiply with non-exact equation, it can be made exact by using integrating factors. So in this type, if mdx plus ndy is equal to 0 is not an exact equation and it is in this form with mx minus ny not equal to 0, then 1 by mx minus ny is an integrating factor of mdx plus ndy is equal to 0. So this model we discuss the example problems. Solve the differential equation y into x square y square plus 2 of dx plus x into 2 minus 2x square y square dy is equal to 0. This is the given equation and clearly it is a first order and first degree differential equation, and clearly it is in the form m dx plus n dy is equal to 0, where m and n are functions of x and y. Here m is y into x square y square plus 2 and n is equal to x into 2 minus 2x square y square. Then dou m by dou y, first I am going to check the condition of exactness, whether the given equation is an exact equation or not. This can be done by finding dou m by dou y and dou n by dou x, and if these two are equal, then we can say that the given equation is an exact equation. Now I find dou m by dou y. Dou m by dou y means the partial derivative of m with respect to y. This is clearly, what is m here? M is x square y cube plus 2y. So I'm using dou m by dou y, that is partial derivative of m with respect to y. So with respect to y means x is constant, x square remains as it is. Y cube derivative, this is 3y square plus 2. So that I have written here 3x square y square plus 2. Similarly, here n is, what is n? 2x minus 2x cube y square. Then dou n by dou x, the partial derivative of n with respect to x. So with respect to x means y treat as constant term. First one 2x, the derivative is 2 minus, here on doing differentiation partially with respect to x, 3 2s are 6 x square y square, that is 6 2 minus 6x square y square. Clearly you can observe that dou m by dou y and dou n by dou x are not same. That means what? Dou m by dou y not equal to dou n by dou x means the condition of exactness fails. So this is not an exact equation. So since it is not an exact equation, what to do? We have to go for the integrating factors to make it exact equation. So here and moreover you can observe that the given equation is in the form y into f of xy dx plus x into g of xy dy is equal to 0. Also mx minus ny, the condition satisfies, it is not an exact equation, and I am going to check mx minus ny value. Mx minus ny, it is 3x cube y cube, and which is also not equal to 0. So this I can turn mx minus ny, you can find easily. M is this x square y cube plus 2y into x minus n value, already we have y square into y. That means what? X square x cube y cube plus 2xy minus 2xy, and what is plus 2x cube y cube. So this and this gets cancelled. 2x cube y cube plus x cube y cube. What will get? 3x cube y cube. So clearly it is not equal to 0. So our all conditions satisfying. So integrating factor is 1 by mx minus ny, that is 1 by 3x cube into y cube, and call this is equation number 2. Already the given equation called as equation number 1, the integrating factor is equation number 2. So then what to do? On getting integrating factor, we multiply this integrating factor with equation 1 so that the equation 1 will become an exact equation. Now, on multiplying integrating factor with equation number 1, what we will get? Y into x square y square plus 2 by 1 by 3x cube y cube multiplied with the m. So this will become in the denominator into dx plus x into 2 minus 2x square y square by 3x cube y cube dy is equal to 0. So on writing individual terms, it is x square y cube by 3x cube y cube. So y cube cancel, x square cancel. The first term is 1 by 3x, that is I have written here. And second one, 2y by 3x cube y cube. Y gets cancelled. 2 by 3x cube y square, that is second term. Plus third term, 2 here we have to write. So 2x by 3x cube y cube. This is the term minus this is the term, dy is equal to 0. Now this equation is an exact equation because the original equation is not exact and it can be made exact by using integrating factors. Already we have multiplied. The reduced equation is now an exact equation. So if equation is exact, it is in the form also mdx plus ndy is equal to 0 and it is an exact equation. Then how to find the solution? Integral mdx, treat y as constant term, plus integral the terms of n not containing x terms into dy is equal to c. Here you have to write dy. Already dy is there. Dy is equal to c. Integral m means 1 by 3x plus 2 by 3x cube y cube of dx plus integral, clearly the first term containing x term. So we have to discard the term. Only we have to write the second term minus 2 by 3y of dy is equal to c. So what is the integration? 1 by 3, 1 by x dx means log x. Then when you are integrating with respect to x, 2 by 3 y cube is constant term. X power minus 3 integration. X power minus 3 means x power minus 3 plus 1 by minus 3 plus 1. That is my x power minus 2 by minus 2 or minus 1 by 2x square. So I am writing minus 1 by 2x square, that is integration term, plus minus 2 by 3 into log y is equal to c. So this I can show in the next slide. That is the required solution of the given equation. So this is the required solution. 2 gets cancelled. 1 by 3 log x minus 1 by 3 x square. What is the answer? I will write a complete answer. 1 by log x by 3 minus 1 by 3 x square y cube minus 2 by 3 log y is equal to C is the required solution of the given differential equation. So this problem comes under type 2 integrating factor model. So we will go one more example and I will solve the differential equation xy sin xy plus cos xy of y dx plus xy sin xy minus cos xy of x dy is equal to 0. So how to solve this equation? The same procedure we follow here also. It is also in the form m dx plus n dy is equal to 0. So what is here m? What is m here? It is m is equal to xy square sin xy plus y into cos xy. That is m. Then what is n here? N dy. That means x square y sin xy minus x into cos xy. So this is n term. Then we have to check the condition of exactness. So how to check the condition of exactness? We have to calculate dou m by dou y and dou n by dou x. What is dou m by dou y? The differentiation of m partially with respect to y. So x constant. So first I will do this. X constant y square into sin xy. This is u into v model. So to differentiate, first on differentiating y square, you will get 2y sin xy treat as constant term plus y square treat as constant term sin xy derivative cos xy into the differentiation of xy with respect to y, that you will get x that I am writing here. Clear? Plus y into cos xy. In doing similar way, y is 1 and cos xy treat as constant term plus y into cos xy derivative minus sin xy into with respect to y means you will get x also. So this is equal to 2xy sin xy plus x square y square cos xy plus cos xy minus xy sin xy. So xy sin xy, 2xy sin xy. So what we will get? Xy sin xy, and what is other value? X square y square plus 1 of cos xy. This is dou m by dou y only. Or this is dou m by dou y. And similarly, we calculate dou n by dou x, the partial derivative of n with respect to x. So this is n. So we do same approach here also. Y constant, x square derivative. So I can remove this y into x square into sin xy. So x square derivative 2x and the sin xy treat as constant term plus x square treat as constant term and sin xy derivative cos xy into with respect to x means you will get the y also. So this is the first term derivative with respect to x. Again minus, again it is x into cos xy. So I will get x1 cos xy treat as constant term plus x into cos xy derivative minus sin xy into with respect to x means you will get y term also into y. So this is 2xy sin xy first term, x square y square cos xy second term minus cos xy third term and fourth term plus xy sin xy. So this is equal to 2xy sin xy plus xy sin xy. This is 3xy sin xy and cos xy on taking outside you get x square minus y square, x square y square minus 1. So this is one element and this is other element. Clearly these two are not equal. These two are not equal means what? The equation is not an exact equation. So if it is not exact equation, what to do? And it is on the form. So see the form. What is the form? It is in the form y into f of xy dx, y into f of xy dx plus x into g of xy dy is equal to 0. Clearly, it is not an exact equation. And also it is in the form y into f of xy dx plus x into g of xy dy is equal to 0. So it comes under type 2 integrating factor, and now I am going to check the value of mx minus ny. So what is mx minus ny? It is x cube, yx square, y square, sin xy, I am multiplying with x, plus xy cos xy minus, multiply n with y, then write x square, y square, sin xy and minus of minus plus, on multiplying with y, xy cos xy. So I am doing here mx multiplied m with x minus n with y. So here x square y square sin xy, x square y square sin xy gets cancelled. So xy cos xy, what is this? 2xy cos xy. This is not equal to 0 clearly. So then what is our conclusion? The integrating factor will be 1 by mx minus ny. So what is the integrating factor? 1 by 2xy cos xy, and call this is equation 2 and this is equation number 1. So here we have done whether the equation is exact or not. That can be made by dou m by dou y, dou n by dou x calculated. If these two are not equal, the condition of exactness fails. So the equation is not an exact equation. If it is not exact equation, we see, and the given equation is in the form y into f of xy dx plus x into g of xy dy is equal to 0. So the integrating factor, to check, we calculate mx minus ny also, and clearly it is not equal to 0. So the integrating factor is 1 by mx minus ny. So that is 1 by 2xy into cos xy. Now, make exact the equation 1 as an exact equation by multiplying with the integrating factor. So on multiplying with integrating factor, 1 implies, on multiplying, xy sin xy by 2xy cos xy. That is 1 by 2 tan xy, first term. I am multiplying this with 2xy, and xy cancel, and 2 and y also there. First term y by 2 tan xy. Second term cos xy into y by 1 by 2xy cos xy. Y cos xy gets cancelled. You will get 1 by 2x into dx. Plus, come to the second term. On dividing with xy sin xy. On dividing, this is 2xy cos xy, y cos xy 1 by 2x dx, right? So now on dividing with 2xy cos xy, xy cancel. Then what is the value? X by xy sin xy. Here x square y sin xy by, what is the term here? 2xy cos xy. So this is tan xy, xy cancel. So what will get? X by 2 tan xy, x by 2 into tan xy. That is the n term. And here it is x cos xy by x cos xy by, this is 2xy cos xy, x cos xy, x cos xy cancel. So 1 by 2y dy is equal to 0, and this equation is an exact equation. Am I right? This equation is exact equation because this equation is obtained from the original given equation by multiplying it with the integrating factor. Now, This is the exact equation. To find the solution, we write integral m dx. Integral m dx means y by 2 tan xy dx plus integral 1 by 2x dx plus integral the terms of n not containing x terms. So in the first term already there is an x term, so we should discard that and we do only 1 by 2y minus an integration of dy is equal to c. So then finally on integrating y by 2 tan xy integration log secant xy by, with respect to x means what you will get in the denominator, y, plus 1 by 2 into integral 1 by x dx log x minus 1 by 2 into log y is equal to log c. So y cancel, 1 by 2 is common term on taking outside, and you can write log x secant xy by y is equal to log c square. So in eliminating both sides log, you will get x secant xy is equal to c square into y, which is the general solution of the given differential equation. So clearly, this equation is not exact equation, and we made it exact by using the integrating factor 1 by mx minus ny, that is 1 by 2xy cos xy. So multiplying and integrating, the required solution will be x secant xy is equal to y into c square, that is the required solution. So this is the type 2 model of the integrating factor. So then we go to type 3 model of integrating factor. Integrating factor type 3 model. Integrating factor type 3 model. So here also the statement is same. If m dx plus n dy is equal to 0 is not an exact equation, and if 1 by n into dou m by dou y minus dou n by dou x is equal to function of x alone. That means what? The resultant is a function of x alone. That means it should not contain any y term like 1 by x, 3 by x, or some x square or some log x, like that only. It is a function of x alone. Then we can, here already it is written where f of x is a function of x alone, then e power integral f of x dx is an integrating factor of m dx plus n dy is equal to 0. This is the type 3. So if m dx plus n dy is equal to 0 is not an exact equation, and calculate and see the value of 1 by n into dou m by dou y minus dou n by dou x. If it is pure function of x, then e power integral f of x dx is the integrating factor. So after getting integrating factor, what we do? We multiply equation 2 with equation 1 so that the equation 1 will become an exact equation. After getting exact equation, we will find the general solution by using integral m dx, treat y as constant term, plus integral the terms of n not containing x terms into dy is equal to c. So here we are going through this model with one example. Solve the differential equation 2xy dy minus of x square plus y square plus 1 of dx is equal to 0. So here clearly it is in the form n dy plus m dx is equal to 0. Here m is written second term, n is written as first term. So here m is, what is m here? Minus of x square plus y square plus 1. And what is n? N is equal to 2xy. Then what is dou m by dou y? The partial derivative of m with respect to y, that is x treat as constant and first term 0, last term also 0, only y square derivative, that is minus 2y. And dou n by dou x, the partial derivative of n with respect to x, that is 2y only. Clearly these two are not equal because it is minus 2y and this is plus 2y. So dou m by dou y not equal to dou n by dou x. Therefore, it is not an exact equation. So the condition fails to have an exact form. So dou m by dou y not equal to dou n by dou x. And also we check the value of 1 by n into dou m by dou y minus dou n by dou x. So what is the value 1 by n? What is 1 by n? 1 by n into dou m by dou y minus dou n by dou x. So what is 1 by n? 1 by 2xy into, what is dou m by dou y here? Dou m by dou y minus 2y. And what is dou n by dou x? 2y. So this is minus 4y by 2xy. So y cancel, 2 cancel. It is minus 2 by x. You can observe that it is a pure function of x. Here the pure function of x is minus 2 by x. So is it satisfying or not? F of x is a function of x alone. So we obtained the function of x as minus 2 by x. Then what is the integrating factor? The integrating factor is e power integral f of x into dx. And that means what? So next slide, minus 2 by x. So minus 2 by x is the 1 by n into dou m by dou y minus dou n by dou x value. Pure function of x. So what is integrating factor? E power integral p dx. P is a pure function of x. So e power integral minus 2 by x. F of x means minus 2 by x dx. So this is e power minus 2 log x, or e power log x power minus 2, or this is e power log x means x. E power log a is equal to a. So e power log x power minus 2, that is x power minus 2, or this is 1 by x square, and which is the integrating factor of the m dx plus n dy is equal to 0. Now after reaching integrating factor, what we have to do is, we have to multiply this with equation number 1. Integrating factor multiply with the given equation. So multiplying the equation, what we will get? Minus of, what is the equation? Minus of x square plus y square plus 1 of dx by x square. So that what I have written here, min plus 2xy by x square dy is equal to 0. What is the integrating factor? The integrating factor is 1 by x square. Just multiply in the denominator 1 by x square, 1 by x square. This is the exact equation. So I am just simplified this. First term x square by x square, that is 1. Second term y square by x square, and 1 by x square minus 1 by x square of dx plus 2y by x of dy is equal to 0. So this equation is an exact equation, and the general solution will be integral m dx treating y as constant plus integral the terms of n not containing x terms into dy is equal to c. So on integrating, what you will get? Integral minus 1 minus y square by x square minus 1 by x square of dx plus integral 0 dy is equal to c. So on integrating, what you will get? Minus 1 integration minus x minus y square, 1 by x square integration. 1 by x square integration means x power minus 2 integration, x power minus 2 plus 1 by minus 2 plus 1, that is minus 1 by x. So that will get plus y by x, y square already there, y square by x. And what is the third term? Minus 1 by x square. Again it is plus 1 by x is the integral term, which is equal to c, which is the general solution of the given differential equation. So clear? Now finally I would like to see one more example on the type 3 integrating factor. So here I have written the problem. Solve the differential equation 3xy minus 2ay square of dx plus x square minus 2axy of dy is equal to 0. So how to solve the differential? Clearly it is a first order and first degree equation. So you can solve this equation by one of the known models. So this can be solved by homogeneous differential equation also, and we can solve this by using this non-exact equation also. First we have to check it out whether it is an exact equation or not. So how to see the exact equation or not? We write what is m here? 3xy minus 2ay square. Then what is dou m by dou y? Dou m by dou y means it is 3x minus 4ay. And similarly, here n is x square minus 2axy. And what is dou n by dou x? The partial derivative of n with respect to x. X square derivative 2x, and this is 2ay. Clearly these two are not equal. That means what? Equation is not an exact equation. Not exact equation. And now I am going to check the value of 1 by n into dou m by dou y minus dou n by dou x. So that is 1 by n. Here what is n value? X square minus 2axy. This is n value. Into what is dou m by dou y? This is dou m by dou y. 3x minus 4ay minus dou n by dou x minus 2x plus 2ay. So this is equal to 3x minus 2x. What you will get in the numerator? X minus 4ay plus 2ay. That is minus 2ay by, here on taking out x, you will get x minus 2ay. So these two terms will get cancelled, and this is 1 by x. It is a pure function of x alone. So we have checked the condition of exactness. It is not an exact equation. And 1 by n into dou m by dou y minus dou n by dou x already evaluated. The value is 1 by x, which is a pure function of x. So this is integrating factor. 1 by n into dou m by dou y minus dou n by dou x. This is integrating factor is 1 by x. Now, multiply the integrating factor with the given equation. Multiply the integrating factor with the given equation. What is 1 by n into dou m by dou y minus dou n by dou x? This is x minus 2ay. This is 1 by x, right? Now, I am multiplying this integrating factor with the equation 1. Then what you will get? 3xy minus 2ay square by x of dx plus x square minus 2axy by x of dy is equal to 0. Clearly, this equation is an exact equation. This equation is exact equation. So how to solve this equation? This equation is exact means we can solve this equation by integrating integral m dx plus integral the terms of n not containing x terms into dy is equal to c is the required solution of the given equation. Just we divide 3y, we'll get here, and here we'll get 2ay square by x, and this is here we get x square by x, that is x minus 2ay dy is equal to 0. So you write integral m dx plus here only the terms of n not containing x terms into dy is equal to 0. See, so it is the regularly we are following this solution in all the types of integrating factor. Here also we do the same thing and we find the solution finally. So this is the type 3 model of integrating factor to make the equations as an exact equations. If the equation is not exact, we use the integrating factor. And what integrating factor to be used for the given problem, that can be decided by the types. Different types are there, and we have discussed in this class type 2 model and type 3 also, and we have seen two examples also there. So with this problem, I conclude my lecture today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.